Yes, a comment or two will be appreciated on what your experience has
Can
been.
you take that again, please?
Yes, I want to hear from you what your experience has been so far on the program for the last 2 weeks you've been in class, and just to get a feel of how the class is going.
Okay, so far so good for me. The class is fine. I was actually thinking Zoom class will be like very difficult because I like attending like the physical class and all. But so far so good. I've been proven wrong, and every facilitator has tried each and every of their best to make sure they take the class as gently and as positive as possible, no matter how much. And I'm glad. I didn't think Zoom class would be this possible, but thank you for the experience.
Thank you. Awesome. Thank you very much. That was good. One more. Anyone?
The class has been awesome in as much as I registered late. Like it is like a shell came out of my eyes since I started knowing, and I started seeing myself improving. Though I am doing a little of the facility, but it's like an eye opener. It has been awesome. I met Mr. Emmanuel. I'm meeting you for the first time, and it's so nice. I'm meeting you. It has been awesome. Seriously, it has been awesome.
Thank you. Thank you so much. Awesome. Awesome. That's the word.
And again, I want to comment on Barakat. She has been very awesome, very, very awesome. We really appreciate her for all she's doing. Thank you.
Fantastic. That commendation will turn to cash. Well done.
By the grace of God, no problem.
So thank you so much. Today, we are looking at facility maintenance strategy. Facility maintenance strategies. In this class, we're going to be looking at some very high-level discussion about maintenance. I know that facility managers, we see ourselves as maintenance people. In fact, almost too much of maintenance. We almost see ourselves as exclusively maintenance, and that's a problem for me. But because we are perceived as maintenance people, it doesn't make sense not to know maintenance or not to be able to do maintenance properly, right? So even though maintenance is 1 in 10, core functions that we perform, or 1 in 11 core functions that we perform, we are branded by it, right? And because we are branded by it, we can't be poor at it. We can't be people who don't know how to do maintenance, okay? So now, but then there is a dilemma. Most people come into facility management, they get into the whole the maintenance officer kind of mode, and then they start maintaining. Now, what they start doing is either what they got from the maintenance manuals of the equipment they have installed, what they got from tradition, what they've learned from people. They end up getting straight into what to do and how to do it. Now, and in many cases, what they even do is not maintenance. If you are waiting for something to break so that you can fix, or observe an error or a fault so that you can repair it or to fix it, to get it to work, that is not even maintenance. You are repairing something that is broken. Maintenance is supposed to make things not to break, right? Now, so if you get into that second level where you are not reacting, you are not fixing what is broken, we say you are at maintenance. But what level are you in maintenance? You are doing what you were told to do. You are doing what you read in the manuals, and you've learned what to do and how to do it. But there is a superior level of maintenance, which we're going to look at into this class. That superior level is a strategy. It is this strategy that defines why, the what, and the how were specified the way they are. if you were told to change oil in a particular machine or engine, for example, change oil is a what? To make sure that machine keeps working, isn't it? So that is what? Then how do you change the oil? What goes into changing the oil is the how. Many of us have learned what and how, but have not learned why. Why should you change the oil in a machine? That comes out of strategy. Someone has already thought through strategy, defined strategy, and developed what and hows into manuals that you have been asked to copy and paste, replicate, act on, and on a continuous basis, deliver on. So if you are just at that level, that point where all you do is deliver on what I've been told, what I've been showed, what I've been demonstrated to me, what's in the manuals, what's in the templates, then yes, I say you are doing maintenance, what and how. Why, you don't know. Today, we're going to elevate you to the third level of maintenance. So the first level of maintenance, which I say is not maintenance, which is basically reactive and repairs, is fixing things when they break. If there's a disruption, you want to minimize the disruption, you want to fix it quickly, you want to be nice to the customers, you want to give them the best experience with every disruption. That is not maintenance, that is repair, that is break and fix. That is not even facility management. In fact, if you are breaking and fixing and breaking and fixing very well and very quickly and very efficiently, you are still not yet practicing facility management. At the basic level of facility management, you are practicing maintenance, which is what to do and how to do it. Today, we're going to give you the third level, which is the strategy that defines what and how you do maintenance. So we're going to look at introduction to maintenance strategies. We're going to look at the 3 key strategies in maintenance for facility managers: run to failure strategy, preventive strategy, and the predictive strategy. After that, we're going to look at a maintenance philosophy, how these strategies are coalesced, how they are brought together to give you an effective, reliability-centered approach to maintenance of your facility. So in essence, we're going to look at 3 strategies, and then we're going to get into the ROCM approach as a way to foster maintenance in your facilities. So I'm going to get right into it straight away. You know, why do we do maintenance? Why are we even talking about maintenance strategy? You know, I started with some people being at the level where they're basically reacting, fixing things that are broken. I said that's not maintenance, right? All the way to the level where you are able to know what to do and how to do it. But why do we get into strategy in the first place? That's what we're going to look at. Just give me a second. Let me check what's causing my disruption around me here. Thank you. All right, so I think the first thing that comes to mind when you acquire an asset is that you want to be able to use it. You want to be able to get value for it, right? From it. So the asset availability is very key. If you acquire an asset and the asset is down, it's not working, it's broken, definitely you're not getting value from it. You want to be sure the asset is safe to operate and that every asset you invest on is preserved and increased in value over time. Well, of course, there'll be duration, but you don't want that duration to be so fast. And then you don't want it to be broken down. You want it to be trusted to work when you need it, which means it's reliable. Your maintenance program should not on its own become an impediment. Now, this is one area where facility managers need to also think about why they do the what and the how. If you are having to shut down an equipment at critical time of need, to do something as good as maintaining it, you are becoming a nuisance to the organization, right? So you need to revisit why you are doing what you are doing. What did we set up that equipment for in the first place? What are we getting from that equipment? How critical is that equipment and that asset to us? Must I do this activity at this time? How much disruption is my maintenance activities going to create for the users of the facility or the assets? All right. And then what about costs? You can't maintain at all costs. In fact, some people have maintained at so high a cost that the owners of certain properties have now decided, you know what, let's just leave it. Don't bother. When it is broken, we'll replace it. Of course, when we get to the strategies, you begin to realize how cost and reliability relates and exactly why certain decisions are taken that you may not agree with management in the course of using assets or running your assets. And then, of course, we want to have optimal performance. We want to reduce capital repairs, on equipment, all those upgrades and overhauling. You want to prolong the life of the equipment as much as possible. Of course, we know that every equipment will go through a degradation curve, a time when it will be so high in performance, the performance dwindles until you cannot do anymore. But then you want to elongate the x-axis on that curve, which is the time or the lifespan of that asset. You want to reduce unplanned downtimes. It's good enough that you have to shut it down sometimes to do routine maintenance. You don't want to also have to suffer the equipment shutting down when you expect it to be up and running. And then all those unplanned repairs, they have more, in fact, it's like a ripple effect on your equipment. One part breaks down suddenly and then it grinds on other parts. You try to get an equipment to do a critical repair quickly, and then you have to bear so much high cost because you are under pressure to deliver quickly. You don't have a lead time that you can wait for, and so many complications can come because you have unplanned repairs. And then, of course, management sees you as ineffective, as not productive, as wasteful, even with all your best intentions. All right, so what do you consider when choosing a maintenance strategy? You think about your understanding of the methods of each of the strategy. Each strategy we're going to talk about has different methods. They have different goals. There are advantages and disadvantages of every strategy. And the advantage and disadvantage of every strategy will not even be the same for every asset category or asset type. Therefore, not all strategies that may be advantageous for one asset class may be useful for another. For example, your block work in your buildings. One strategy may work for maintaining and managing your block work and your roof and your floors and your doors and your windows, most of the static equipment or components you have in your facility. And that strategy will be very wrong if you try to apply it to moving equipment with moving parts. For example, where you have engines and machines that have rotating parts that are having friction on an ongoing basis. The strategy will have to be different. So you have to think about how you put together a maintenance strategy. If you've not defined a maintenance strategy, your maintenance plan, no matter how proactive you think you have been in developing a maintenance plan, you are making a mistake. In fact, without defining a strategy for every asset line item, most of the things you are doing regarding maintenance of those assets are all wrong. Okay? So even if you've copied what people have done before that has worked for them, you've brought it into your own space, you start thinking about the why and developing your own strategy for that asset, you may be making a huge mistake, even with the same asset. And that's what we're going to learn in today's class. So this is elevating your thinking about maintenance beyond the day-to-day mundane task of maintenance to why we even have those activities set in place in the first place, right? And it will drive straight to the level of strategic thinking before you acquire your assets. I mean, think about it. Many people just think about which is more expensive compared when they're comparing alternatives when acquiring assets. They don't look into the complications, the access to spares, the life cycle cost, the operational difficulties they will have with that asset once it's been installed. You can install and acquire cheap, and then ongoing, you have all kinds of issues. So why you need to learn maintenance strategies before you even acquire the asset, before that decision to go for option A over option B, you have looked at the ongoing strategy for maintenance and how that strategy is going to be implemented on an ongoing basis. Otherwise, you may make a very big mistake in your choice from the onset because you looked away from the life cycle assessment of that asset. It's important that there's a good understanding of how equipment fails in order to make a good choice of the most appropriate maintenance strategy. Every component of your building will not fail the same way. I talk about degradation curve. The degradation curve for various assets will follow different pattern. Some will be very steep, some will be very slow and shallow. What that means is it will not be the same rate of failure or deterioration that you're going to experience in all your assets. That's one. Then two, the kind of impact you have on assets, for example, environmental impacts, a rate of use might have different level of deterioration impact on your facility or your assets and components. And as such, you must think about what strategy to deploy in managing such facilities so you can get the best result, or at least reduce the rate at which the condition deteriorates or increase the lifespan of that asset as much as possible. Okay, so by the time we start looking at the strategies themselves, it will be easy for you to relate with these introductory aspects. How do you choose a maintenance strategy? What are the criteria? How much do you have and how are those financial resources allocated and applied? If you have a system where there is working fund, money is always kept in a pool, and you can be doing all your proactive plans without having to go back, new approvals and disbursement and so on and so forth, you might think about a strategy that does not require you stocking up or doing anything big at a time. You just go with the flow. What's due on Tuesday, the material coming on Tuesday, and you get it done and you just go on. But if you have to go with long cycle of capital acquisition and disbursement and approvals, then you probably say, okay, you know what? Instead of to go through this cycle over and over and over on a weekly or monthly basis, I better stop for a quarter. So your strategy is going to be affected by allocation of available resources, including the kind of manpower. If you have staff in-house to handle all of the activities in-house, your strategy will be different from when you have to call out a vendor who will have to take your request, process it, send it through some of the staff, and get them to your site, right? The strategy will be different. So depending on the kind of resources and how they are available and allocated, your strategy will be different. And we're going to be able to think as facility managers after this class, so that you are no longer asking, how is it done? How is it done? You will know why it is done that way. So you can know exactly how to tweak, change things, adjust, and still get a good result. When management says, we want to save costs, we want to cut out this, we want to cut out that, you're not going to be the one fighting and saying, no, it's not possible. This is the only way it's done. Because you know why, you know strategy. You know you can switch strategy and still achieve your results. All right? So the organizational maintenance process will affect how you choose a strategy, the technology you have in place, what kind of equipment, what kind of tools and software you have to manage it, what kind of technology you already have in-house, the cost of that technology, the equipment itself. You know, there are some equipment or assets you have in your facility that are going to be so critical. I mean, take hospitals, for example. There are certain live, machines that, people's life depend on. The maintenance strategy is going to be different from strategy for grounds and lawn maintenance in that same hospital, even though ground and lawn maintenance is always super important for every facility, right? You have to adapt to various criticality levels, the skill of your personnel, the training you have in place for them, the quality of service, and the customer expectations are all drivers. So you might actually apply one strategy for maybe a chiller system for one client, right? And then you go to another client, the customer expectation is very different. This customer probably cannot afford a redundant system where you have a backup in a server room, for example. You know how one customer will have enough backup so that you can just say, you know what, I'll run this one reactively. If one fails, another one is there to work, you know, and so on. So that strategy may work for that customer, but then the next customer says, no, I can't afford that. I'll have only one in this place, and that one cannot fail, right? I'll have to switch strategy because I know what's expected of me, what the customer expects of me. So many considerations on choosing your maintenance strategy. But then, while you are the professional trying to, balance your work, try to be proactive, trying to deploy these strategies, you will find out that for many of us, this is probably the first time we are discussing strategy for maintenance. We know of maintenance plans, we know we create a schedule, we know we put frequencies and so on and so forth. That's a different topic, but that is so elementary compared to how that strategy is developed, how it's evolved. So many facility managers actually start their career and work their way up and retire without really understanding maintenance strategy. It's even worse when you have management in the core business and you are trying to talk strategy for maintenance and they don't understand you. They can't flow with you. That can be a big challenge. So part of what we are trying to do with this FM diploma is get everybody on the same page, get people to understand as much as possible. So break that barrier of not understanding what strategy is. And then, when you begin to pick strategies for different assets, every strategy have different impact on budget, for example, different impact on cash flow, for example, different impact on customer and user experience, and so on and so forth. And so you may have pushback. And then some organizations don't even have a budget for maintenance. I can't blame the organization. The FM didn't create a budget for maintenance because the FM believes that if something breaks, it's always an act of God. And when it breaks, we have to go and apply for funds to come and fix it. And that's one without creating a plan for fixing it. If you're doing this break and fix strategy or approach to maintenance, then of course, there will often be no maintenance budget. Some FMs will say, oh, well, we really know we don't know what is going to break. So there's no way to estimate it. You have to be able to estimate it. You have to be able to have a budget for maintenance. And if you want to get a sense of what your future maintenance costs will be, look at your previous repair and maintenance expenses. That can give you a kind of a pattern of failure, give you a trend that you can build on to create a proactive plan. So you can have a budget. But again, your budget will always come under attack. Maintenance budget will always come under attack. There's so much you can do about that. And one of the ways you can prevent your budget from coming under attack is to use justification, line item justifications, what we call budget difference per line item that speaks to the maintenance strategy. And when we link that back to the strategic facility plan again, that we discussed in our week 1, that you can see how they tie up. You are now beginning to speak to the higher level objective of management by saying, I want to ensure that there is zero injury. I want to improve work staff productivity. I want to reduce lost time to injury. I want to reduce costs that we lose in breakdown. When something breaks down, for example, and nobody's working and we're not getting results, we want to reduce that. You are contributing that as a way to justify your strategy. Because if I know that my organization's power supply, if it's shut down for 1 hour, I can estimate what a 1 hour power loss will cost my organization. By the time I'm putting my maintenance program together and I'm adopting a strategy that's going to help me prevent that, I'm using that as a justification for my strategy. Save the organization so much from power failure, exactly citing previous instances and having numbers the management can see. So if management says, instead of them to just pick that line item and say, no, this is too expensive, let's cut it down. By the time they see your justification, avoiding downtime, avoiding productivity losses, avoiding loss of value to your organization to so and so amounts, of course you've experienced it before, then that justification becomes easy to relate with. In fact, you get to a point of management to say, you know what, I think we should actually buy more assets or double it or create a redundant system to support a strategy. And then sometimes you've put together maintenance strategies that don't align with the organization's strategy. So every time you have this pushback from management, think again. You might have created a plan that will be in conflict with management. It may be very subtle. For example, you have created a system for spending money in trickles. When the organization does not get money in trickles, the organization gets money once in chunks. Your strategy is now misaligned because when a chunk comes, it's only that trickle they will still spend. But then when you need the next trickle, there's no chunk and there's no money to deal with that trickle. So you have to create a strategy that aligns with bulk activity at the time when we get our chunk inflow. That is alignment. Okay? And then you could have created a maintenance strategy that focuses on the wrong aspect of organizational success. An organization that is doing a lot of activities online and making so much money from online activities, we expect you to focus your maintenance budget and effort mainly on how to keep the server up, how to keep the IT systems up, make sure your IT is okay so that you don't have masts being blown out and communication system being blown out and so on and so forth. That is where they will expect your focus to be. But then if you weigh everything on physical premises, when you're not really getting much out of physical premises, you may struggle to prove alignment of your maintenance focus with organizational strategy. So your strategy and organizational strategy must find alignment, very critical. All right? And then many facility managers don't have maintenance plans. By my own experience and surveys in the industry, this is about 80 to 85% of FMs. And for those who have plans, they have that spreadsheet that just lists all the assets, and you have all of those colored boxes that says, we'll service this at this time, at this month, at this week, at this day, and that's all they have in terms of plan. There is nothing specific as to what to be done when that servicing is due, and there's no proper reporting mechanism for tracking and reporting what was done when that time comes. And that's what we're going to change in this class as we move on. So let's just get ready. Today we're looking at the strategies, and then the next time we're going to look at the maintenance planning, how to create a simple maintenance plan. So we all have one. I believe that you've all received your project docket, so you see the maintenance plan. We just gave you a small simplified template for how to put together your maintenance plan. So right now, don't wait for the program to finish before you start creating your maintenance plan. The whole idea of giving you that document in advance is so that as you learn anything in class, you start acting on it and you have the tool and template to start working on it. Maintenance goes hand in hand with an organization's objectives, and so there must be a clear understanding of maintenance objectives to ensure proper allocation of maintenance resources. If your maintenance objectives align with that of the organization, there's a very high likelihood that everything you want to do will always find approval. So now to the first maintenance strategy. This maintenance strategy is the most common. It is the most popular. But many facility managers don't seem to realize that it's a strategy and don't seem to apply it deliberately as a strategy. It just happens to them. It's called run to failure. This is also called reactive maintenance strategy. It's also called corrective maintenance strategy. It's also called emergency maintenance strategy. Every of the unplanned maintenance strategies are merged into this run to failure strategy. Because there are two types of maintenance, primarily. One is the planned maintenance, the other is the unplanned maintenance. While the planned maintenance has more than one strategies we're going to look at today, the unplanned has just one strategy. Every unplanned maintenance strategy is called a run to failure strategy. It simply means that you don't do anything. The maintenance activities for that asset is zero. If it fails, threatens to fail, manifests a fault or an attempted fault or a disruption or a slowdown or whatever it is that is tending towards failure, you take action to bring it back. That's basically what run to failure is. You restore the equipment to its intended function. Now, just looking at the name of the strategy, run to failure, sounds like, why do I want to run into failure? And then looking at the definition, don't do anything. Just allow it, just keep using it until it is failing before you act to restore it. Sounds like something we should be working against. But no, it is a smart strategy that is actually best and most applicable for more than 90% of all the assets you will ever manage in the built environment. Think about it. Let's look at your building from roof to garden. Roofing sheets, ceilings, trusses in the roof, concrete beams and columns in the structures, slabs, the walls, the windows, the doors. All of those things that are built into the foundation of your buildings. Your fences. Just keep naming them. Just keep naming them. If you look into your buildings, your tables, your chairs, your mirrors, your toilet bowls, your toilet seats, your cisterns, your urinals, your taps, just keep naming them. For those of us who are managing offices, your projectors and laptops and computers, desktop computers, just look around your television sets. There is no better strategy for most of these static equipment and components than the run to failure strategy. Now, why are we teaching this? You must consciously assign the strategy so that you can know what and how, because now you know why you are going to maintain it that way. So even if what is zero, nothing, how is zero, nothing, those items still remain under your watchful eye. You are still in control. You are still making sure that they give maximum value. So that's the whole idea of saying you are having a strategy. If I have a strategy for managing this table or this desk that I'm on right now, with run to failure, I will not be calling a maintenance guy to come and unscrew and screw it back every now and then for me to know that it's working. No, I wouldn't do that. I'll keep using it, but very often I'll be checking for its stability. Very often I'll be checking for bolts and nuts that are falling off. I'll be checking for handles, and locks that are malfunctioning, and then restoring them. That is what the strategy calls for. Fix. Reactive maintenance has the philosophy of repair equipment when it breaks down. If it doesn't break down, then don't fix it. So part of trying to understand why this is even a strategy in the first place, think about equipment that have very, very complex maintenance procedures. When I was growing up, I had one excursion to a glass factory. where they put on, all of these natural silicon sealed items into furnaces that are very hot. They melt sand into liquid and mold them into glass. I was curious. It's so hot. This furnace is so hot. How do you even carry out maintenance on them? Chief engineer says, this furnace has been on for 18 years. And it will take us months. It will take us months. If we even decide to shut it down to do a maintenance right now, it will take us months to wait for it to cool down enough for us to do any kind of maintenance. And I said, aha, this, you will not put any other strategy. You kick it on, you use it until it coughs and puffs and stops. And then you have to deal with it. Think about your wristwatches and wall clocks. Complex mechanisms. You hang them up there, put them on, drop them until it develops a fault, stops, or something, battery goes out, or something happens to the spring. You don't do anything. Are you conscious about that strategy? Or is that a mistake that you're allowing it like that? So when things are going to be costly for any other strategy, you deploy run to failure. What about easy to replace components? Think about your light bulbs. Light bulb is there. If it doesn't stop working, I will not change it. If it doesn't show some black ring or some patch or something cracked on one side, I won't do anything. I just use it. It's run to failure. It is more economical to use this strategy to run it. But if I have a service expectation to make sure the light is always on, what will I do? Ensure I have bulbs on ground and ensure that I can meet my 10 minutes, 15 minutes changeover time to have a new bulb in. That is a strategy. I am now acting the strategy by consciously ensuring that I have some bulbs on ground. But if I can't even have a minute to change the bulb, I can't use this strategy. For anything I cannot have a downtime allowance for, where the impact of its failure is so critical to the client that the client cannot give me even a minute to allow it to fail, then I can't use run to failure because failure is not possible. So even for light bulbs, example, for instance, I will no longer allow the bulb to go out before I change it. I will make sure I have a policy of replacing every bulb that is 6 months old. Because I know that the turnaround time of a typical incandescent bulb, if I'm using the LED bulbs these days, are probably 2 years. Turnaround time on the average, 2 to 3 years. So I'll say, you know what? Every 12 months, I take them all down and put a new one in, a new set in. That way I will never have a downtime. That is no longer a reactive run to failure or a corrective maintenance strategy. That is now a different strategy we're going to look into. If I can have allowance for equipment failure because it has a minimal impact, then of course I will deploy this strategy. Okay? So reactive maintenance is actually present in all maintenance strategies as failure is not perfectly predicted. And also equipment still break down even after maintenance action has been done. In essence, you need to be conscious about what this strategy is and how you are applying this strategy. Because there are certain implications of deciding that I'm going to use this strategy to manage my roof, my walls, my furniture, my fittings, and so on and so forth. And those implications are what we're going to look at. You don't have to put people on standby because you don't have routine activities to be performing. Initially, it looks like a low cost, especially for equipment that are moving parts. Moving parts, I wouldn't recommend this strategy. And we're going to see why I won't go to the next strategy. And then there's not much to plan. If what you have to plan, the plan says don't do anything, how much planning do you still need to do, right? But the labor cost will be high every time you have an incident. Same with your repair costs. The staff that you have assigned to routine activities in your maintenance, your normal operation, will be suddenly diverted to go and deal with repairs that just rear their ugly heads when you were not expecting it. So your staff resource will not be efficiently used. Equipment will not be reliable, especially for equipment with moving parts and critical equipment, because you cannot predict when they will fail. And that is a problem for certain assets. And then frequent downtime will not be useful for you, especially for assets that are critical, that affects the success of your organization. And then this is the critical part: difficulty in controlling budget. Your plan for a reactive maintenance strategy asset line item is don't do anything. But it does not preclude you from creating a budget so that when it does fail, you have money to deal with it. That's not when you start writing memos. There are 200 chairs in my conference room or in my auditorium in the church, and I've adopted run to failure as a strategy for managing those chairs, which means I will not be doing maintenance activities on them on a monthly or weekly basis. But typically, from history and from other data I've acquired, as the chairs get older, the number of chairs that break on an annual basis increases. That's simple understanding of the division code. So if I plan to replace 5% of the chairs, 10 chairs last year, or I had 10 chairs that actually failed that I had to fix last year. This year, if the chairs were 5 years old last year, they are now 6 years old. There's a likelihood that 12, 13, 15 might be impacted this year or more. Of course, I'm making a forecast. So, am I going to replace them? Am I going to repair their footings? Am I going to put new accessories on them? Am I going to just weld and correct certain things? I need to create an estimate for that. I'll put that amount in my budget. So while I have a budget for the routine activities, the fixed activities that other strategies are accounting for, I'll also have a budget for the unanticipated repair. Well, it's anticipated, but you don't know when, because I'm using a reactive strategy. Management will look at the line item and say, why are you putting a budget for chairs that are perfectly okay? I'll say it's my reactive or run to failure strategy. This sum of money is to respond to the likelihood of 15 of my chairs having a deficiency during the year, which means I could spend it. I may spend less, I may spend slightly more, but let the margin of error not be significant, because your forecasting and prediction should be close enough to give management confidence to leave that money for you. But that's not the only problem you have. The second problem you're going to have is, as the months roll by, every other budget line items are decreasing proportionately with the periods. But the run to failure budget line item will not decrease. That creates a complication, because on a monthly basis, management wants to understand why exactly are we having that money tied down when we have the need for money elsewhere and we cannot use it. So there'll be a lot of pressure to reappropriate that fund to something else. When you want to hold your ground, you want to keep making sense of the fact that you have adopted a strategy and this failure may still happen. You may even be in November, and then there's a major convention or a major event where the place gets really overfilled, and then you have 10, 15, 20 chairs requiring repairs. Boom. I told you, I'll need this money. And then sometimes nothing happens. The money was actually not spent. No chair was broken. For goodness sake, how can you now justify having a budget for fixing chairs for next year? In fact, The fact that chairs did not even break at all is the more reason, is more justification for having money in your budget for chairs next year. Because the wear and tear is only increasing. There's no magic about it. How do you make that case? That's where the difficulty comes from. But if you deploy and talk about strategies that you are deploying for your operations and maintenance and for your managing of your assets of your facility, and you can link the criticality of that asset availability. Take a boardroom sitting, for example. It may not be a set of chairs you sit on every time, but will it be something nice for your board members to come and find out that they don't have enough seats because of my broken? So think about that. Initial capital cost investment will not be maximized, and that's advantage process. And then there will be interference with planned work. Just the same way you have people who should be doing planned work being drawn out to come and take care of unplanned activities. So that's all about that first strategy. It is the most, my opinion, important strategy. And don't think that because other assets that you deploy other strategies for will fail, therefore the strategy has changed. Strategy is something you set. You work with the strategy. Strategy remains what it is, even if you fail to implement the strategy. And it is the most important strategy for me, again, because it accounts for a majority of all our assets. What makes FM look so confused and disorganized and always running from pillar to post is because they don't think of the assets that require this strategy and deliberately assign the strategy and make plans to ensure that there's resources to deploy this strategy. They go from hand to mouth, cap in hand, every time something happens. Rain falls and the window is blown out. Oh, it's an act of God, right? They do not envisage or anticipate that a window could be blown out. So you can have a plan for, I have 500 windows. 2 or 3 could be blown out this year. Last year it was 1, the year before it was 2 or 3, and so on and so forth. That's the kind of thing we're talking about. You forecast and you plan and you budget for it. This second strategy, the preventive maintenance strategy, is very familiar to many FMs. The routine things that you do on a regular basis. In fact, the word PPM is a buzzword in facility management. You put certain assets on a spreadsheet, and you put some frequencies, and you put some activities that need to be within those frequencies. You put, who would do it, how much it's going to cost, and you build out something. Oh, yes, fantastic. Because at certain intervals that have been defined by the frequency, those activities must be repeated on that asset. Doesn't matter whether the equipment is in good shape or not in good shape. You just have to perform the things that have been specified within those frequencies. That's what planned preventive maintenance is all about. It adopts a time-based or a run rate approach. A time-based is weekly, monthly, quarterly, annually activities. A run rate is if you have a clock in the equipment that measures its rate of turning and working, then you can use like a generators, your photocopiers. They have a clock in them that tells you how many tons they make, and how they work. So you don't necessarily need to say, oh, my car has worked for 6 months, let me take it for servicing. No, you probably need to track the mileage. That's the run rate. The generator, the hours run, that's the run rate. So whichever method you adopt will depend on the kind of assets that you are putting your preventive maintenance on. Preventive maintenance seeks to reduce unplanned downtime and repair costs, but it may not always detect failures before it occurs, since the approach is not condition monitoring. It focuses on performing pre-scheduled maintenance. So you set what needs to be done and you do it. The equipment, whether it's in order or not in order, perfect or not perfect, you just have to do what you said you would do. That's what planned preventive maintenance strategy does. Straightforward, right? The whole idea is stay on the safe side. If I keep doing what the manufacturer said I should do, I will not be blamed. And I have a record, because of course, if you're doing routine activities, you just keep a record of, when it was done, what was done. And you have a sense of accomplishment. You're doing something. It's also a sense of an alibi. If it fails, because it will still fail, even if you do everything. Well, I've done my part. Now that it fails, it's not my fault. I'm a good FM, right? So run to failure is, the preventive maintenance is the safest approach to maintenance. It is maintenance for dummies, if you ask me, because what needs to be done is defined, how it should be done is defined, when it should be done is defined, everything, just read it and follow it line by line. You're good. You don't need to think or overthink the process. And because it's been pre-planned and pre-arranged, the likelihood of sudden failures or sudden, disruptions is reduced. So you're safe to a large extent. Okay? And then, of course, there's higher performance, reduced downtime, fewer repair emergencies. Equipment seem to work better. They're often safer, especially because not all equipment you will use this strategy for. Not all assets you will use this strategy for. For the ones that is most appropriate for, then yes. Does it have some disadvantages? Of course it has. You're going to spend a lot more because you're going to have standby people doing routine activities. And there's so much activity you're performing that are not needed. Equipment is working perfectly. We are spending money on it. Just because, of course, you don't want it to break down the line. But think about what you are doing. If you're critical about the cost of your maintenance, you ask yourself, if I take out a filter, has that filter actually finished doing its work? Or am I wasting some life of this filter? If I take out that oil, has it finished doing its work, or am I wasting some life out of the usefulness of this oil? So we say there's a lot of unnecessary maintenance. That's just the key downside of this approach to maintenance. In terms of giving you peace of mind, super, but then you pay a very hefty cost because you are doing something on a continuous basis, whether it's needed or it's not. And that's what this third strategy is coming to fix. The predictive maintenance strategy is also called condition monitoring, condition-based maintenance strategy, because it evaluates equipment condition before acting on it. Now, going back to draw parallels from the two previous strategies to how we got here. In the first strategy, run to failure, it has to actually exhibit a fault. That's what that strategy requires. In the preventive, I don't even check whether it has a fault or not. In fact, in its perfect state, I keep doing what I'm doing persistently. In the predictive, I don't want to waste all our resources in preventive maintenance, but I don't also want it to break down. It cannot break down. For it not to break down, I must preventively monitor it, track and trend its condition based on operating parameters that have been set in place by the manufacturers. Take your generators, for example. It will operate at a certain temperature. It will have a certain level of vibration. If it's more than that, there's a problem. It will have certain sound level. If the sound level is more than that, there's a problem. It will emit so much carbon and so much density of this and that. These are all operating parameters. They have been specified. I know the ranges. If my equipment keeps working within those upper and lower specification limits of those operating parameter ranges, then run it. No problem. I just keep monitoring those and tracking those operating parameters. If it stays within those ranges, I'm fine. Temperature stays within the range, I'm fine. Keep running everything. Just keep enjoying the assets, but keep your eyes on those operating parameters. That's what predictive maintenance is. If one operating parameter is beginning to trend out of that upper and lower specification limits, the moment it begins to trend out of a certain mean that I've been monitoring, I begin to tell myself, if it continues like this, I can plot it up and say, at this time, this is going to fail. And I don't know exactly how long I have to investigate. It's still working, still working. It's not even shown a fault yet. It has not failed, no error. It's still working. But an operating parameter is beginning to go out of range. It's not yet out of range, but once any operating parameter is out of range, that means I have a repair. That means I have a fault, right? It's not yet there. But because I'm monitoring it to stay within a certain mean, and it begins to go trend away from that mean, I can tell how long it's going to take for you to cross that line for breakdown, or that I have to shut it down to make a repair. So I investigate now, and I take specific actions to redress what is causing that operating parameter to go out of range. That is predictive maintenance. Let me bring these three strategies closer to you by using your body, which is the most perfect machine ever made, to analyze it. One common ailment that attacks us as humans in Africa is malaria. So you could decide to adopt a run-to-failure strategy for your body. Whenever malaria strikes, the headache, feverishness, cold, sore throats, the pile up, tummy ache, weakness of the body. This malaria, I can't go to work. I have to go and treat malaria. That is run to failure. But you could also say, you know what? There's this tablets I can take every Sunday to make sure malaria does not come near me. If there's any malaria trying to raise ugly head around me, these tablets will take care of it. On Sunday morning, whether I feel perfect or not, I take that tablet as a ritual, just to make sure that I don't break down with malaria. That is preventive maintenance strategy. But I could say, you know what? Why do I want to endanger my liver with so much drugs that I don't even need? I'm feeling perfectly okay. Why should I be taking a tablet every week? I'm trying to switch to predictive. Of course, the tablet is not cheap, not free. And then it also causes other dangers to my liver and my kidney and the rest. So why would I do that? I'm going to predictive. So what do I now do as predictive? I will do a test every Sunday morning. I'll prick my hand, take a little sample, put it in the test indicator, you know, some kind of indicator that tells me what color is +2 plasmodium, which one is just the normal level of bacteria, malaria in our parasite in our system, right? Because I check it, yeah, this is the normal range of malaria parasite in everybody's system. We're all well with this normal malaria. Next week, I check again, it's within range, I'm fine. Next week, I check it within range, I'm fine. But the day I check, and instead of seeing green in that indicator, I'm seeing amber. I'm feeling perfectly okay. But by seeing amber, I know that, if I don't do something now, by Wednesday, I won't go to work. Immediately, I go and get a malaria medication. I take it now, and then by the time I get to Wednesday and Thursday, I'm fine. I don't have any symptom. I'm not sick. I'm not down. By Sunday, I do my test again. I'm fine. I'm in green. I continue doing the test all the time. That's how you relate the reactive or run to failure to the preventive and the predictive. So the real advantages of the predictive is that you save a lot, But the major pressure is that data monitoring is an intelligent job. Condition monitoring is an intelligent job, not something you do with the run-of-the-mill technicians who don't know why. It's only people who understand strategy that can get to the point where they can do predictive. Because when you see, if you don't fully understand the operating condition parameters that you are monitoring, and you don't have control over the testing mechanism or data acquisition mechanism, you might make a wrong interpretation, make a wrong diagnosis, and your equipment will go down. It was going down and you were reading something else. So the risk is quite high. Maintenance is not carried out based on predetermined dates, but based on the actual condition of the equipment. This implies that maintenance is performed at the ideal time and resources not wasted on the unnecessary work. Convenient scheduling of maintenance activity is made possible by predictive maintenance. So that time, that you are tracking and trending, you are acting. Take the engine of the generator, for example. The temperature is trying to go out. It used to stay around 40 to 44. And then for the last 1 week, it has gone from 46 to 48. I know that the upper limit is 90 degrees. So what do I do? By the time it gets to 50, I can plot. By the time I plot, I know exactly what day, at this rate of rise, it will get to 90. I know how many days I have to act. So I go to the manual and I go through, troubleshoot for overheating, check radiator coolant, test, check, it's in order, not radiator. Okay. Check the oil, take it, test viscosity, take dissolved metals, check density, looks okay. What next? Check the oil pump. Is the pump actually pumping the oil through the engine? Just checking. And if I find out that one pump is what fails or works intermittently that is causing this issue, I stop, I change that, and the temperature comes back to normal, and we're all happy again. All that routine maintenance I would have been doing will no longer be necessary. But this maintenance comes at a front-end cost. Data acquisition tools. These are some of the operating parameters that your equipment will be required to work within certain ranges, upper and lower specifications. And as such, you must have systems in place for tracking where you are at a particular time relative to each of these operating parameters, okay? So that you can know that it is within range or going out of range. But again, the beauty of these three strategies of maintenance is for equipment that you will typically deploy a preventive maintenance strategy for. If you use corrective for it, you will spend 10 times on 10 times the cost of maintenance, because breakdown has not just the cost of the increased breakdown repair or restoration cost, but also the cost of downtime, which is the cost of lost productivity. So corrective can be very expensive, especially if it affects your core production or core productivity of the organization. Preventive is 5 times and predictive is the cheapest. So in essence, predictive maintenance is the cheapest form of maintenance if you can pull off the technicalities around it. The level of data and all it takes to acquire those data, analyze it properly, and make best judgment out of it will make predictive, an effective tool for you as a facility manager. So why use predictive maintenance? Allows planning for and scheduling of corrective maintenance, prevent unplanned failure of equipment, reduce purchase of spare parts, reduce maintenance costs, improvements in maintenance planning, increase system availability and reliability. Maintenance is performed while equipment is still in service. So it didn't break down by itself, and you didn't schedule it for maintenance. You just keep investigating and acting in such a way that the equipment can keep running. And then it eliminates or reduces disruption and allows for early detection of problems. Maintenance is performed when necessary or needed. This is very different from preventive maintenance, which is done whether it's needed or not. You just keep doing the same routine on an ongoing basis. if you look at the advantages and disadvantages of predictive, you will see that it tries to fix the problems of reactive by making sure there's no breakdown at all. And then it also tries to fix the excesses of preventive by making sure that you don't do anything unnecessary just to prevent a breakdown. That's the beauty of this approach. But it's really, really, really top-end approach. I mean, think about it. If you were the one managing the Kainji Dam or any of these major dams that are providing power to the whole country, how often will you shut it down to do maintenance on them? You have massive dashboards with sensors everywhere, bringing in data, telling you exactly, how each operating parameter in every pump, every turbine, every aspect of it, even the shaft and the pulleys, how they are working, how the cables, temperatures are being monitored. You have all of them, how the oil temperature, everything be monitored on dashboards. That's all you'll be doing as a predictive maintenance. Anything going out of range, you see that trigger, and then you go and act. That's the only way to manage very large equipment. I mean, think about it. If you're managing a gas turbine where the engine oil for replacement is probably 30,000 liters of high-grade synthetic oil that runs into millions of dollars, will you be replacing it every 250 hours? You will set up a whole lab that takes a sample of that oil every hour just to be monitoring how the oil is doing. Because that oil itself is a major asset. You're not pulling it out to throw away. That lab will be there monitoring that oil, just the oil. And as they're monitoring the oil, there are so many things they'll be seeing inside. Every component in an engine, for example, are made with different materials. Some are made with tin, copper, iron, magnesium, different type of material, carbon and the rest. As these elements wear and tear, the oil collects them, right? So if you do oil analysis on a continuous basis, you can tell which particular components in your machine or engine is wearing faster. You can even predict when a particular shaft or pulley is going to have a problem next year and prepare, because you are seeing the level of wear and tear just by analyzing the oil on an ongoing basis. You will never have a breakdown, and yet you will never have to, stop the equipment to go and do maintenance. Now, at the level of strategy, we are talking about each asset. One asset, what's the strategy for maintenance? The next asset, what's the strategy for maintenance? But as a portfolio of assets, we need to think about maintenance that gives us high reliability and low cost. How can we achieve that? That's where RCM comes in. It's a philosophy of maintenance that helps you select, pick and choose strategies for various assets with the goal of having overall portfolio performance at the least cost. We call it the economics of maintenance. We combine different strategies for different assets just to ensure that overall we get the best experience, we get the least cost, we get the highest performance and reliability and quality asset availability. It takes a longer view of the assets. So if you're going to deploy a strategy for your window ACs or your split ACs that is different from what another person is deploying, it is because of your ROCM analysis that you can make such a decision. The ACs probably are not critical, or their downtime will not lead to productivity losses. I will put them on run to failure just to reduce my routine maintenance costs. Whereas another person cannot put his own split ACs or window ACs on run to failure, because you need to do your reliability-centered maintenance analysis on your entire portfolio. And this is how it's done. You use a template like this. Is this asset a small part of equipment? Is it non-critical? Is it equipment that is unlikely to fail? Is it an equipment that has a redundant system? Now, this is where many, you have to think again sometimes. You may have a critical system like air conditioners in your server room. Very critical. Server room cannot go hot. But the server room requirement is 1 unit of a 2 horsepower AC. Can carry that server room conveniently. But just to make sure you don't have any issues with that server room, management has decided to put 2 extra 2 horsepowers, which means you have N plus 2, or 1 extra 2 horsepower, which means you have N plus 1 strategy of redundancy in that server room. If I get the pleasure or privilege of having an N plus 1 or N plus 2 for any critical asset, I can adopt a run to failure strategy for that asset. Because I have a redundant, fixed in place, replace alternative, that once this one shows any fault, the AC stops cooling, it starts making noise, it starts dripping water, I shut it down, I put the next one on, and then I take it out for repair. I don't need to necessarily come to do routine maintenance on this particular AC or any of the ACs, because I always have the time to use one or the other. A pumping mechanism. There are redundant pumps. If one fails, I just switch my valves and I start using the next one. What kind of maintenance do you want to put on the pump? I just use run to failure. So I save that money that I would have used for routine maintenance activities on that pump. And then I do the same thing, analyze the ones that are supposed to be on preventive maintenance, analyze the ones that are supposed to be on predictive maintenance using these guidelines. And you can adapt or adjust this framework for ROCM to suit your organization's requirement, your strategy as an organization. You can move some of these criteria around just to create your own ROCM hierarchy. And then you use this to look at every asset one by one and say, this asset, where does it fall into? Then I now assign that strategy to that asset. And I'm assigning that strategy to that asset because it is the cheapest cost that I will spend if I use that strategy for that asset. If you look at the advantages and disadvantages of ROCM, they are very close to those of predictive maintenance. Why? Predictive maintenance tends to fix the errors of the other 2 strategies. The ROCM has that advantage or that overarching consideration for all your portfolio, considering all 3 strategies. So what does this mean? Items that I run to failure, I can drop down to preventive. If they are still expensive, I can drop down to predictive. I keep targeting the least cost for altogether for my portfolio. So if you look at these advantages and disadvantages, you see that they're very similar to predictive because it tends towards progressing, for critical equipment, progressing you towards predictive. So it's FM that have advanced in maturity, professionalism, and expertise that can actually start adopting ROCM and predictive. In the meantime, everyone else just starts by being able to move from normal repairs that is not maintenance yet into maintenance where you know what and how, and you have a schedule for doing that, which is planning, and then you move to the level where you understand strategy and stay safe on the preventive until you have what it takes in terms of knowledge, resources, skills, technical ability to move to predictive. But again, because you understand strategy, all of the assets you're currently ignoring. When I see your maintenance plan, for example, I'll see like 10 items. I'll be wondering, are these the only assets you have? Let me see your asset register. I'll see 3,000 items. I say, why do you have 3,000 items to your asset register and your maintenance plan has 10 items? Because you've only focused on the preventive maintenance items. So that's why I would normally tell you, scrap preventive maintenance plan. Create your maintenance plan that includes every line item in your asset register. You can filter out a preventive maintenance plan from that. So you can now say, these are the ones I've adopted preventive maintenance for. Just the same way you can filter out a reactive or run-to-failure maintenance plan from that, where you can now say, these are the assets I've adopted a run-to-failure strategy for. And you do the same thing for predictive. So that's our lesson for today. You have assessments for this class. We're going to go into questions now after taking a 5-minute break. And I want you to look through your notes and pop up your hands for acknowledgement so you can ask your questions after this short break. Thank you. Okay, so I'm not sure it's 5 minutes, but if you have your questions now, you can pop it up. Let's take care of it. All right, so let's hear from Jude.
Okay. Thank you, Mr. Paul. Thank you for a very insightful lecture today. I must say that I learned a lot today. I have 3 questions. The first one is, how can RCM be used in a place where power availability is of optimum necessity?
Okay. Should I take the questions as they come instead of forgetting some? Let me take the first one, right?
Yes, please.
Okay. How can RCM be used in a place where power availability is of optimum necessity?
Correct.
Okay, so you are looking at your power assets and what strategy to adopt for your power assets.
Yes, please.
Okay, good. So the strategy for when you're in such a situation is to use preventive, which is your PPM, to ensure that your power assets are always up and running, right? Now, there will come a time when the cost of PPM will become a concern to management. You know, there are some companies that have gone bust because of FM and overhead costs. It was so critical until it started threatening the existence of the business altogether. When that time comes, your response should be to maintain the criticality, but reduce the cost by migrating from PPM to predictive. Which means at some point in the future, you will still be able to maintain that level of criticality and availability, but you'll be able to drop down how much it costs you when you invest in sensors and IoTs and monitoring devices that give you top level information and data of things before they happen, right? So you can actually stay on the safe side with preventive, and then later migrate to an advanced high-tech approach of predictive that costs you less and still assures or guarantees your criticality or availability of those power assets.
Okay, thank you. Excuse me.
Yeah.
But in this instance, can one say that looking at the cost of preventive maintenance, has gone up, and now looking at options of trying to see how best to still continue to provide a stable power supply at, will I say, a managed cost now, because in the way one is looking at probably eliminating as much as possible cost of maintenance. The maintenance will be there, but it will not be at a very, very reduced level. So in trying to achieve that, migrating from one type of power supply to another, can it also be termed an RCM or a predictive?
Okay, so changing your asset class is what you are doing. That's really not the maintenance. Maintenance is maintaining what you have, right? Now, if you are changing it, let's take, for example, I'm switching from diesel generating systems because they are too expensive. I'm switching to an IPP, which means I'll get a new transformer or get some lines or get some, receiving equipment, or I want to switch to gas generators. That means I'll change my generators or change certain components in my generator combustion systems, and then get some, gas reception manifolds and piping into my place. That's really not maintenance. That's a change from one asset class to another asset class. Even the new one I'm changing to will still require maintenance, right? Now, so everything we do in FM has the maintenance side and has the operation side. Energy cost in terms of cost of fueling or the final output is operations. But the equipment itself has a maintenance cost, which is the routine activities or the non-routine activities we do to keep them running. There are two components. So for generator, the maintenance cost of the generator does not include the fuel cost. So the fuel cost is an operations cost. If I was to change completely that generator or certain components of the generator to change from one fuel type to another fuel type, I'm adjusting or changing my asset class. That asset, I'll still have to decide what kind of maintenance strategy to deploy for it, even the new one.
Okay, thank you very much. That's really very clear for me, and I have my points now to make my case to the management.
That's good.
All right. The second question I want to ask is, can RCM be used in cooling an open office or common areas?
Okay, so I think the question really is, can you deploy predictive maintenance? Because RCM does not apply to one asset. It applies to your portfolio of assets. But predictive maintenance can be applied to one asset. If I have a central cooling system, maybe a chiller, air-cooled or water-cooled chiller system installed, right? If I have sensors for carbon levels in every space, carbon dioxide level in every space, so that that sensor will send triggers to one damper that will open to allow oxygen or close to maintain energy efficiency and so on. If I have something that tracks the water temperature, the quality of the water at the cooling tower, for example, if I track soot levels within the within the ducting system, and I can take action to automate a flushing system, maybe a fan that is built into the piping system to evacuate all soot or dirt or dust from that system, piping network, and so on and so forth. I might be able to use those equipment and sensors to gather information on the conditions of various components that make up my air handling units, piping and ducting, control systems, refrigerant lines, my compressors and all that, and deploy predictive maintenance still, right? But I must know the right equipment to be in various spaces to give me the kind of data that will help me determine that that particular component is operating within its functional specifications. If I can't get sensors that can give me that information, I cannot move to predictive.
Wow, this one for food for thought. I'll have to still probably engage you further on this privately, offline.
Yes.
And the third question I want to ask, and the final one, is are there softwares that can help in using RCM, or RCM softwares that can help one in managing one's assets or equipment for maintenance?
Yes, I don't think there is anything there are no softwares for. It's just a matter of doing research. Till now, we still do condition assessment, for example, using calculations and snapping pictures and writing down defects codes, right? But there are softwares for snapping, determining condition, and calculating of the condition index automatically. So softwares are always available to automate whatever we do in facilities. The moment you have an energy management system, or you have a building management system, or you have a building automation system installed in your facility, you already have systems that are capturing data that can help you, deploy or perform ROCM. It may not just be called ROCM, but it's ROCM because at the end of the day, it's giving you enough data to tell you whether those components of your buildings are operating optimally or not.
Okay, thank you very much, Mr. Paul. I really do appreciate this. Thanks.
You're welcome. Moses.
Okay, good evening, Mr. Paul. Thank you for the teaching. It's educative and has really elaborated my knowledge in terms of maintenance strategy. Okay, now I want to talk on borehole, for example. Okay, and I want to use my location as an example. I've always seen borehole as although I'm just getting to get the knowledge that there is what we call run to failure, and then run to failure. I know about preventive, and I know about predictive, but to me, I don't think for borehole, because borehole, the pump is the main component of borehole is the pump. And it's like a submersible pump that pumps the water out into from the pipe into the tank, So, but I don't think there should be like a preventive maintenance for borehole. I've always think that this borehole is working. The water are not colored. The water are crystal clear. And I'm thinking, why should I maintain borehole? Because I will have to unloose the screw, bring out the how do I determine that how do I know that this thing is time for me to maintain this thing, So I'm thinking, when you are not talking about run to failure, I'm thinking that's the best strategy that should be used for borehole. But I don't know if I'm right also.
Well, I can't give you that to be a conclusion. The reason is that no two boreholes are the same. If you drill a shallow borehole in a sandy environment, no matter how you create that mesh around the pump, silt, sand will still, over time, besiege your pump and can become a problem for the pump. The pump can even stop working. There are some wells that have been drilled, especially shallow wells, where silt and sand lead to a point where they virtually block the bore, that there's not enough room for the pump to suck out water without sucking out silt and sand. So if you know that that's the kind of experience you have, your boreholes sometimes don't produce enough water in certain seasons, or brings out sand in certain seasons, or the machine starts going hot and not bringing out water at all, then you know that you have to put a maintenance program in place for desilting that well. You have to compress it. You put in a compressor in there, and it forces all the silt that has, settled into your well, forces all of them out, clears it up, and gives enough depth for water to gather so that your submersible can see a good pool to suck clean or fresh water for you from, right? And then sometimes you may not be conversant with what's going on within your well if you don't go and do this routine checks on it every now and then. So depending on, if I have an industrial borehole, for example, very deep, very big, very sophisticated, those kind of expensive boreholes that you find in some industries and in some estates, for example, I probably would do those checks less frequently because there's a very high expectation that this system is very reliable. But I will make sure that even with that system, if I'm doing a run to failure strategy for my borehole, I will have one extra submersible pump installed. If water supply is critical to my estate or my assets, I cannot say because I'm doing run to failure, I will not wait for the borehole to collapse or the pump to start not working or burned out before I'll now react. No, I wouldn't do that. I'll keep certain components, capacitors, the spare pump and all that, so that I will be able to respond immediately it throws up a fault if I'm doing run to failure. So you could do your borehole run to failure, you could do it preventive. The choice is yours, but you must understand the kind of borehole you have, and you must understand why you are doing what you are doing. Or that if you've had boreholes in that neighborhood, for example, for 20, 30 years, and boreholes have never collapsed, there's never a case of water drying out, sand and silt don't come out of your pumps, and pumps don't stop pumping, you probably will say, you know what, I'm going to do run to failure, get a spare pump and keep, right? But if there are incidents of borehole disruptions around because of the water table, because of the soil aquifer, because of the depth of your borehole, and all that, then I would say go for preventive to be on the safe side. So you can always, do all those routine checks and desilting and clean out your pumps and servicing it and putting it back for a fresh new lease of life. Okay, so the choice will be yours ultimately. That's what I see.
Okay. Thank you very much. The borehole that I have is industrial borehole. I think the option of getting a spare pump will do for me, because the borehole has been in function for the past for some years now, and then it has not given any problem, and the waters are crystal clear, no any issue. So I think the run to failure and having an alternative pump will do for me.
Failure is perfect. Yes, run to failure is perfect for you. And just run with it. I see some people go ahead. The same thing applies to transformers. Many of us think that, oh, transformers will have to be serviced twice a year or once a year. I don't believe in such ideas. I don't believe that you should go and start opening up high tension panels and transformers because you want to do routine maintenance on them, right? You could actually run them to failure and make sure you have your backup plan in place and defend your strategy if that's what you are deploying. Because many equipment or assets that are very complex, once they are loose, certain gaskets are opened, and then you've assessed it, and certain oil has received oxygen from the air. They were in some vacuum before when they were created from the factory, and you expose them to air, you do one or two funny checks on them, and you lock them back in there with some of those, glues you find in the market these days, and then you say it's back to functioning. The problem that would not have happened to that equipment for 25 years, you created it. So be very conscious. There are certain complex equipment that you prepare for, not to tamper with them. Don't bother, just leave them alone. If they have been running, let them run. Back yourself up for when they fail. Olufemi stepped out. Okay. Envoy, take your question.
Okay, I think you partially just answered it, but I'll still ask anyways. Would you advise a run to failure approach or strategy for, let's say, an escalator or a lift machine, due to the fact that you can't really detect faults from an external inspection, even if it's done on a daily basis?
You can always detect, you can always do predictive on elevators. Elevators use cables and pulleys and motors. Every part of an elevator can have sensors that gives you information. All those pulleys and cables will have, you can have sensors that determine how hot they get, sensors that determine how fast they work and how slowly they work, the noise level in your motors, the heat temperature level in your motors. All of those things can be used for predictive maintenance approach for elevators, right? So yes, you can also deploy run to failure successfully, provided you back yourself up with what it takes. So to do a run to failure strategy, you must understand the failure pattern or the failure mode of your asset and determine what are the likely things to fail so that you can back yourself up with those. Things that rub on each other that wear and tear. Things that, things like capacitors that take the heat for surges and other fluctuations or spikes in power. Those are the kind of things that you prepare. Contactors, for example, in certain panels, you put spare contactors aside so that in case something happens, a trip, a fuse, a blown, you can replace them. Those are how to run to failure. Run to failure is not just by mouth. It's a scientific approach. So you have to prepare yourself for reacting when it does fail, okay?
All right, thank you so much, sir.
You're welcome. Okay, let's hear from Olufemi. Olufemi, ask your question.
Good evening, sir. Yeah, I raised my hand when I heard the other person who talked about the borehole.
Yes.
And if there was a need. So my question is, I wanted to know what kind of maintenance approach is best for a borehole, because this is it. Where I came from, it was actually, I would say biannual. We used to do the compression of borehole biannually or sometimes annually, or not up to that. But where I am presently, for 2 years now, I've not even compressed the borehole and it's doing fine. So there was this time last year I spoke with my boss about it. So he was laughing and saying that borehole is like the deepest in Lekki Phase 1. He gets, and was saying he doesn't see it come. So what I'm trying to say here is, what kind of maintenance actually are we supposed to use for this kind of? We have 2 boreholes actually working fine. The other one wasn't, but we fixed it. But my concern is this has been working for a long time. I took check on the raw water to see changes or see if it's more of iron and all that, but it's still the same. So I don't know, are there boreholes that can be really deep to the point that we've not serviced for 2 years and our water is top quality?
Very good. So I think it was part of the explanation I gave when you stepped out. You know what you have. Now that you understand maintenance strategies, you know why you should adopt a particular strategy for your assets. Oh, your borehole is the best and the most stable, doesn't fail, and so there's no need for doing routine maintenance on it. And I'm all for that. Do not go opening up things that are working perfectly, especially if there are no history of them failing in the past, right? But run to failure is not just by mouth. You have to prepare for run to failure as a strategy. That borehole has a pump. That pump has a capacitor somewhere. There are contactors somewhere. There are cabling somewhere. Those things can fail, right? What you need to do is understand what the failure modes, what can fail, and prepare yourself to respond. So first, adopt a strategy. Nobody's going to fight for your strategy as far as you have a firm justification for that strategy. And then ensure that that strategy goes with a plan. I have so and so contactors in place or have access to it so that within a 2-hour period, if any contactor fail or any switch or fuse fails, I will replace it, right? That's exactly how to do run to failure. Do not just ignore the assets. It's no longer in your radar. No, that's wrong. That's not maintenance at all. If you are maintaining it and you're using run to failure, you are conscious about it. You have plans in place to ensure that anything that can cause a disruption, you know, and that you are prepared to react to that disruption. Is Okwe here now? Okwe or Jay? All right, I think that question from Olufemi was our last question. Have a good evening. I'll see you again on Wednesday. Blessing has a question. Okay, let's take that quickly.
Good evening, sir. Okay, mine is just like a comment or something. I don't know, because when you in my own place where I'm working, I actually think we do more of run to failure maintenance, because when you're dealing with residential people, once you want to do the preventive maintenance thing, they will start giving you excuses like, okay, I'm not around, we'll come back to so and so time. This time is not convenient for us. Okay, until you do a meal, even when you're doing a meal and you're telling them, okay, I want to come do and check this, or I want to run this, or I want to do this, or I want to just check if this is working. They will always have something to say for you to just reschedule and all. So run to failure is mostly what we do on our side, because you are dealing with human beings, you're dealing with different people with different opinions and all in our own place. So it's sometimes difficult to actually relate with them when you want to tell them, okay, we are doing a routine maintenance on a plan preventive something, and somebody will tell you, okay, I'm rescheduling it. Can mine be 1st of January? Or can mine be 24th of February? And on that date, when you're okay, no problem, ma, oh, no problem, sir, they'll still have something to say. So you don't come back and do your maintenance strategy or carry out anything you want to do in their particular apartment, because it's, like I said, you're running residential, and also sometimes ours is difficult.
Okay. Now, the lesson learned, Blessing, from this is, if you are doing run to failure strategy, you are intentional about it. You're not trying to do preventive, and because you have obstacles on the way for doing preventive, you assume that you are now doing run to failure. No, that's wrong. Okay? If you switch from preventive to run to failure, you will no longer be making any attempts to schedule visiting, going to do this or that. No, you create a new strategy that does not require any of those, and communicate to all your clients to say, our strategy has shifted from preventive strategy. These are the reasons why we're going to run to failure of reactive strategy. This is the communication lines for this and that reports of failures. These are what we have put in place: spare bulbs, spare pumps, faucets. We have flush handles. We have, you look at all the common things that would normally fail in the various apartments. You know, we now have them in stock as we shift from a preventive strategy to a run to failure or reactive strategy, right? That is conscious, that is intentional. If you are doing preventive and you're having obstacles and you could not implement them, your strategy is still preventive, it's not run to failure, okay? OJ, are you ready now? Habib.
Yeah, good evening, sir. Good evening. Good evening, everyone in the class. Yeah, actually, my question is very straightforward because you have really mentioned this earlier. But I just want to shed more light on it because when you talked about the transformer, in my own scenario, what I have issue is because we have a very good relationship with IBEDC, you know, and occasionally they come to our organization and they'll be like, it's been long, we carry out a routine maintenance on our transformer. That is a normal thing to do, like once in every 2 years. Fine, I don't have it with it. So
Habib, you have to know exactly what activities they want to perform. You have to know what exactly they are coming to perform. For transformers, you can actually
we did a maintenance on one of transformer. It's not even, we did a maintenance. I mean, we did a routine maintenance, like inspection and all those things, like the annual servicing of the transformer. Hello, sir. Are you getting me, sir? Yeah, we did a annual maintenance on the transformer, and we got to discover that one of our 2 transformer is a dummy transformer. Let me put it that way. It's not even working at all. So what we have now is just one that is working. So I am being scared to carry out another maintenance. It's better I just leave the one that is working than to touch it. I don't know. And it's stated clearly on the SLA that this annual maintenance of transformer should be carried out. So I mean,
now let me help you. Let me help you, Habib.
Sort of a dilemma.
I understand. You see, when we take
thank you, sir.
When we take the maintenance planning class, I'll teach you some things about maintenance scopes. And then you learn a little bit about servicing as a term in facility management. We've allowed the word servicing, that means nothing or everything, to replace specific actions and activities. Your transformers have certain checks and tests that should be done and are required to be done by statutes, by law. Every 2 years, certain checks and tests must be done. And one of it is a sampling of the oil, you know, the coolant oil inside your transformer. For those that uses oil, getting a sample of that oil and taking it to the lab to check for its dielectric properties. It's a statutory test. Your transformers have temperature ranges you should operate in. Every 3 to 6 months, you should have a thermal imager used for imaging that transformer. Take a picture of the transformer so you can see the what we call the thermal profile or the heat image of that transformer at peak load, at least twice a year, if possible 4 times a year. In all of these ones I'm describing, there is no intrusion into the transformer. So in effect, you can be carrying out maintenance on equipment without intruding into them. When I talk about panels, high tension panels, for example, you can use a thermal imager just to take screenshots of the thermal profile without opening it up. So sensitive equipment that are complex, you could use those data acquisition tools that we described when we're looking at predictive maintenance. So those assets are no longer on run to failure. They are not on preventive. They are now on predictive because you are using those tools, sensors, to gather data that tells you whether they are in good shape or they are tending towards failure. Okay? Olufemi's hand is up again. Let's hear from you.
Sorry, sir. I just remembered something now. We have 2 to 3 generators on ground. I'm using my place as an instance.
Sure.
And we have an IPP power supply. These generators are on maintenance services with Jubilee and Bros. But the truth is, the last time we serviced is close to 8 months now. And actually, it should be either 200 hours, after 200, running as 200 hours, running it for 200 hours, or I think a lot of time, they say 2 to 3 months. But now my boss has refused to allow them services. So there's this guy that told me, the generator guy that told me that I want to confirm if filters actually get fault bad. If you don't, so we used to start, we warm the generators, the technicians, they warm it to make sure it runs for a while. But I don't know. What do you think, sir? Should I advise my boss to allow this guy to come?
If you warm it for up to 15 minutes every week, eh?
Yes, sir.
Kill those contracts.
Yeah. I'm probably withdraw our money from them. I guess
those
you. Thank you very much.
And give them,
I just pay, they don't say we can't get the money.
No, you can get the money back. Kill those contracts and convert it into a call-out servicing contracts, right? So whenever it's due, if it is 200, 300,000 for one servicing, that's all you pay. Come and service this one, it is due.
Even if it's once in 2 years.
Yes. Now think about it. Do you know that every building abroad where they have 24 hours power forever, they all have standby generators?
Yes.
Every building abroad have massive standby generators. Do you think they go and service them every 3 months?
So we're not supposed to put that preventive plan in place at all.
It is, yes, you put the plan in place, right? And then let the plan be that it's 250 hours or 300 hours, whatever you have decided, right? But part of that plan is to make sure that you test it weekly to be sure that it is still in order and it will respond. It is warmed up, right? So that's what you keep doing. And generators can do 25 years in the basement just by warming it up every 6 months, for example, and probably changing the filters and the oils maybe once in 2-3 years, because every liquid has expiry date. So you need to know the expiry dates on the oil you use. For example, if you use a synthetic oil, the expiry date may be longer, maybe 5 years, right? But if you use a normal SAE, 2040, for example, you probably are talking about 12 months or 24 months expiry, because it is there inside the gen and you're basically just testing every few months. So what you're doing by testing is running it through the engine, but it does not pick up enough, how would I put it, friction to lead to viscosity loss, to lead to high dissolved solids and all of those things that cause oil to deteriorate. But the oil can expire. So you need to check when the oils can expire to make sure you do a routine holistic servicing for that period to change everything on both oil and filter. But the point I'm making is, instead of allowing those 1 year contracts for 3 million and 2 million, kill all of those things and arrive at what it costs for one servicing and change the contract into a call-off contract. So anytime you call them, they come and service for the fee.
And that's it.
Yeah.
Thank you, sir.
You're welcome. All right, thanks everybody. Have a good evening. See you on Wednesday. Bye-bye.
Bye, Mr. Paul.
Bye. Bye. Thank you very much.
Bye-bye, sir.
Bye,
Mr.
Paul.
Thank you.
Thank you, Mr. Paul. Thank you, sir.
Bye, sir.
Bye.